what's out there beyond the Milky Way? If you take a step back and look at the universe as a whole, one thing becomes clear. It resembles a vast cosmic web, woven from glowing filaments of galaxies. Between these filaments stretch enormous regions of near-total emptiness, voids hundreds of millions of light-years across. These immense cosmic voids are so colossal that even the largest galaxies appear as mere specks against their backdrop. Some stars burn through all their fuel and vanish long before a single photon could cross from one edge of such a void to the other. Even the primordial echo of the Big Bang, the cosmic microwave background, gradually fades into silence within these dark, mysterious depths. And now, the time has come to journey straight into the heart of the great cosmic void. Our cosmic neighborhood. When you consider the true scale of the cosmos, our planet appears as nothing more than a tiny rocky fragment hurtling through endless darkness at tremendous speed. For billions of years, Earth has orbited the Sun at an average distance of about 150 million kilometers. But the real boundaries of our solar system extend far beyond that. Modern astronomy places the outer edge of the system at the distant fringe of the hypothetical Oort cloud, roughly 100,000 astronomical units from the Sun. Beyond this limit lies the interstellar vacuum, a space so incredibly empty that on average there's just a single hydrogen atom in every cubic centimeter. The nearest stars in our galactic neighborhood are several light years away. In fact, a photon leaving the Sun's surface could reach Proxima Centauri without ever colliding with a single particle of matter. This all-encompassing void isn't just empty background, it's a fundamental part of the universe's large-scale structure. It permeates the entire Milky Way, separating stars, planets, black holes, white dwarfs, and other cosmic objects with vast, impassable gulfs of near-nothingness. The local group. Our galactic neighborhood, the local group, occupies only a tiny patch within this all-pervading cosmic emptiness, which itself is just a small part of a far vaster cosmic void. Invisible yet powerful threads of gravity bind together the three largest members of the group, the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy, along with roughly 100 smaller satellite galaxies. Together, they form a gravitationally bound collection of matter spanning about 10 million light-years across. The local sheet. Our local group, however, is itself part of an even larger structure, a flattened filament of galaxies known as the local sheet. This pancake-like arrangement contains several hundred galaxies, stretching about 46 million light-years across and only about 5 million light-years thick. In turn, the local sheet belongs to the Virgo supercluster, an even more massive gravitational assembly. But right next to the local sheet, the cosmos takes a dramatic turn. The rich tapestry of stars gives way to a colossal black void, the local void, also called the local hole. Essentially, the local sheet forms one of the walls of this vast cosmic bubble. Its other boundaries are loosely defined by the Perseus-Pisces supercluster and the Pavo-Indus supercluster. Inside the void itself, sparse corridors connect it to neighboring emptinesses, the Sculptor Void and the Hercules Void. Driven by the expansion of the universe and the gravitational pull of surrounding matter, the local void is slowly growing. Today, it spans roughly 150 million light-years in diameter, with its center lying at least 70 million light-years from Earth. Remarkably, the nearest edge of this void is astonishingly close, just 23 million light-years away. Because of this proximity, the local void covers about 40% of our night sky. However, its central region is hidden from view by the bright plane of the Milky Way, filled with luminous stars and glowing nebulae. Still, its outer edges remain observable. Galaxy NGC 6503, the local void. In 1951, just north of the constellation Hercules, astronomers discovered a small spiral galaxy NGC 6503. Later observations revealed it sits almost dead center inside the local void. Its appearance is strikingly colorful. Its spiral arms glow with bright regions of ionized hydrogen, while vivid blue nebulae mark active stellar nurseries. The galaxy's core, however, is veiled by clouds of cool gas and dust, giving it a rich, deep brown hue. NGC 6503 spans about 30,000 light-years across and lies roughly 17 million light-years from Earth. It's moving toward us at a speed of approximately 27 miles per second. As it drifts closer to the local sheet, NGC 6503 is expected to sweep up fresh interstellar hydrogen from its surroundings. This influx of gas should trigger a surge in star formation. Models suggest that in a few billion years, the number of young stars in this galaxy could double, causing this modest galaxy to shine with renewed brilliance. Its motion offers a compelling real-world example of how cosmic voids like the local void likely took shape over time. How cosmic voids formed. The seeds of the universe's large-scale structure were planted in the first moments after the Big Bang, when a turbulent mix of energy and matter created random fluctuations in density. Immense cosmic upheavals carved out regions that were slightly denser and others that were slightly emptier than average. Over time, gravity amplified this contrast. Matter flowed toward the denser areas, forming the glowing filaments and galaxy clusters we see today, while the sparser regions lost even more material, gradually emptying out into vast cosmic voids. Scientists believe the main phase of void formation wrapped up between 10 and 1 billion years ago. Interestingly, galaxies found inside these voids are roughly the same age as those in dense filaments, a key observation that strongly supports our current understanding of how the universe's grand cosmic web evolved. Virgo supercluster. Given the ongoing expansion of the universe, it's likely that in the future, the local void will grow even larger and more empty, while the Virgo supercluster will gradually break apart into several smaller, isolated groups. Today, the Virgo supercluster is a massive collection of roughly 2,000 galaxies packed into a region about 200 million light-years across. Its total mass is equivalent to about 1,000 Milky Way-sized galaxies. The supercluster borders the Centaurus and Pavo Indus superclusters on one side, but on the opposite side, it abuts one of the largest known voids, the Taurus void. Taurus void. Studying this region is extremely difficult. Most of it lies in the so-called zone of avoidance, an area hidden from our view by the bright star-filled plane of the Milky Way. The glare from our galaxy's stars drowns out the faint light of distant objects, while interstellar dust absorbs and scatters their radiation. Nevertheless, infrared observations have given us a glimpse into the structure of the Taurus void. It spans roughly 200 million light-years across, with its center located about 150 million light-years from Earth. One of the most striking features is the sharp boundary between the nearly empty void and the dense concentration of galaxies just beyond it, the Perseus-Pisces supercluster, one of the most massive structures in our cosmic neighborhood. Such a well-defined edge is typical of filamentary cosmic structures, yet infrared data show no significant concentrations of ordinary matter along this border. This suggests that unknown physical mechanisms may be at work there, mechanisms we have yet to understand. Despite its name, the Taurus void may not be as empty as it appears. Subtle distortions in the light from background galaxies hint at the presence of vast clouds of gas and dust deep within the void, potential nurseries for future galaxies. Other theories propose enormous concentrations of dark matter, the mysterious substance that makes up most of the universe's mass but has never been directly detected. Even more speculative ideas suggest the possible existence of antimatter or even exotic matter with negative mass at the hearts of cosmic voids. However, these hypotheses lie far beyond the boundaries of established physics and currently cannot be tested experimentally. To date, only 2 isolated galaxies have been found deep inside the Taurus void. Galaxies UGC 2627 and UGC 2629, Taurus void. UGC 2627 is a spiral galaxy resembling the Milky Way, while UGC 2629 is a small elliptical dwarf. Both lie almost exactly at the heart of the Taurus void, roughly 185 million light-years from Earth, and are separated by only a few 100,000 light-years. There may be other lone galaxies hidden in this region as well, but our view of them is blocked by the bright, dusty disk of our own galaxy.
Laniakea, the Virgo supercluster, is itself part of an even grander structure, the Laniakea supercluster, a vast assembly of over 100,000 galaxies stretching across 520 million light-years. At its gravitational heart lies the Great Attractor, a mysterious concentration of mass located about 250 million light-years from Earth. Laniakea, in turn, belongs to an even larger galactic flow. If we zoom out even farther, it becomes clear that this entire system is surrounded by a black abyss of unprecedented scale. Within this emptiness, the light from distant galaxies fades into obscurity, and even neutrinos, particles that barely interact with matter at all, would need billions of years to cross it. Remarkably, this colossal void was discovered only 10 years ago.
The discovery of a giant void. In 2013, a team of astronomers led by Professor Amy Barger at the University of Wisconsin-Madison was mapping distances to galaxies when they made a stunning discovery. Laniakea and the surrounding superclusters are encircled by a colossal cosmic void, larger than any previously known. This finding forced scientists to rethink some fundamental ideas about the large-scale structure of the universe, revealing a reality far more complex than anyone had imagined. The KBC void. Research by Amy Barger, Ryan Keenan, and Lennox Cowie appears to have led to one of the most significant astronomical discoveries of the 21st century. Our Milky Way, and its entire cosmic neighborhood, resides inside the largest known void in the observable universe. Named the KBC void after the initials of its discoverers, this immense emptiness is roughly spherical and may span up to 2 billion light-years across. According to calculations, our galaxy sits about 1 billion light-years from both the center and the edge of this great cosmic void. The discovery of the KBC void solved a long-standing cosmological puzzle known as the Hubble tension. Measurements of the universe's expansion rate based on nearby galaxies consistently yield a higher value than those based on distant objects, a discrepancy that had baffled scientists for years. The KBC void provides a compelling explanation. Galaxies within it, including the Milky Way, experience extra-gravitational pull from massive structures outside the void. This creates a stretching effect that makes nearby galaxies appear to recede faster than expected. Notably, the KBC void is so enormous that it encompasses other well-known voids, including the local void and the Taurus void. Because it contains entire superclusters, it appears less empty compared to smaller voids. Yet even this colossal structure is just a tiny speck against the backdrop of the entire observable universe, which spans approximately 92 billion light-years in diameter. The scale of the universe. Large-scale maps of the cosmos reveal numerous dark regions comparable in size to the KBC void.
Most of them fit well within current cosmological models, but a few exhibit strange and hard-to-explain properties.
The Eridanus supervoid, also known as the cosmic microwave background cold spot. One of the most intriguing features in the cosmos is the Eridanus supervoid, also known as the cosmic microwave background cold spot. It's estimated to be between 500 million and 1 billion light-years across, and lies roughly 6 to 10 billion light-years away, making it one of the largest known structures in the universe's large-scale web. Located in the southern sky, it covers an area several times larger than the full moon, yet it's invisible to optical telescopes. Only microwave observatories can detect it. These instruments revealed that the temperature of the cosmic microwave background in this region is about 70 microkelvins colder than the universal average, an anomaly 4 times more extreme than any previously observed. While the integrated Sachs-Wolf effect, a slight cooling of CMB photons as they pass through large underdense regions, can account for part of this dip, it explains only 25% of the observed signal. The remaining 75% may involve the influence of dark energy or unusual properties of dark matter within the void. But the true nature of the CMB cold spot remains a mystery, one that future generations of scientists will need to solve.
Final thoughts. When we gaze into the cosmos, we see hundreds of millions of galaxies, each filled with billions of stars, trillions of planets, and countless other celestial objects. Together, they weave a luminous cosmic web that spans the observable universe. Yet all this splendor is little more than fine dust sprinkled across an ocean of near total emptiness, the void that makes up the overwhelming majority of space. It is this emptiness that reveals the true face of the cosmos, mysterious, silent, and perhaps holding the answers to the deepest questions of existence. Or maybe, in its depths, there is nothing at all, only endless, incomprehensible darkness. Will we ever uncover its secrets? Only time will tell.
Subscribe to the channel. The most fascinating and mysterious content is yet to come.